Okay, fine. So when you have a five-membered ring, okay, suppose you have a five-membered ring, so then your principal axis will be C5, okay, and definitely you will have C2 also. So you can see that this is your C2 axis, okay. If you rotate the molecule 180 degree, you will get equivalent structure. So similarly along this also you will have one C2, okay. Along this axis also you will have one C2. So you have C5 axis, then you have 5 C2, okay, 5 sigma V, as well as you have sigma H. So again you will have what, D5H point group. If you have 6 membered ring, 6 membered ring, so that time your principal axis will be C6, you will have 6 C2, you will have 6 sigma V, and you will have sigma H. So that means what, you have D6H point group, okay, D6H point group, okay. Now next, suppose you have H2O2 molecule. So H2O2 molecule, I told you already that it has different structures. So first of all I am writing cis H2O2. So cis H2O2 means like this: hydrogen, oxygen, oxygen. Here you have hydrogen. So this is your cis H2O2. Next you have trans H2O2. So trans H2O2 means what? You have hydrogen, then you have oxygen, oxygen, hydrogen, like this, okay. And another you have open book like, open book like, okay. So here you will have oxygen, oxygen, okay. You have hydrogen here, you have also hydrogen here, above the plane you have hydrogen. So if you see here, what you have, C2 axis is present here. So you have C2 axis and 2 sigma V, so that will lead to your C2V point group. If you see here, so here you will have this C2 axis along y direction, so you have C2y, and this molecular plane will be perpendicular to this C2y axis, that already we have done. So you have C2 and sigma H, that will lead to what, C2H point group. And if you have this kind of thing, so that time only C2 axis will be there, so you will have only C2 point group, okay. So these are the three things which is important for your H2O2, okay, fine. Now next, suppose you have trigonal planar, trigonal trigonal planar, okay. So suppose you have like this, A is the central atom, okay. Now here you have B, B, B. If all the atoms are symmetrical, so this is basically same thing. Suppose you have BH3 or BCl3, same type of molecule. So the principal axis will be what, C3, then you will have 3 C2 axis, then you will have what, 3 sigma V, and this molecular plane will be what, sigma H, okay. So C3 axis will be along this is your C3 axis, okay. C2 will be along this, okay. You can place along this C2 axis, this is your C2, this is your C3, and sigma V is also present along this only, this is your sigma V. So C3, 3C2, 3 sigma V, and sigma H, that together leads to what, together it leads to D3H point group, okay. But suppose here you have different atom, here you have C, and here you have two atoms B, okay. Then what will happen, so that time C3 is not your principal axis of symmetry, that time it will be your what, C2Z, along Z direction C2 axis is your principal axis of symmetry. And this is similar, so now check sigma V, so you can place a sigma V, you can place a plane along this, okay, and another will be along this. So initially what you have, C2Z, and you have 2 sigma V, so that leads to what, C2V point group. C2V point group. Okay. Now suppose you have here A. Okay. Here I have C, here I have B, and here I have C. Okay, so again the two atoms are same and one atom is different. So again you can see that along this you have C2 axis. Okay, if I rotate the molecule 180 degree along this, so this 2C will interchange their position and V will remain here only. Okay, so if you have this, like, so you have C2 axis and you will have two sigma plane also. One plane is like that. Okay, so then that time CC is actually becoming mirror image to each other. Another plane will be like this. Okay, so again you have C2 axis and you have 2 sigma V, so that leads to what? C2V point group. And the last one, suppose you have three different point groups. So here you have B, here you have C, and here you have D. So if you have three different groups, okay, or different atoms attaching with your central atom, that time you will have no principal axis of symmetry. So that time only one thing is present, that is your molecular plane. Okay, that time only molecular plane is present, and if only molecular plane is present, so that is actually gives you what? CA's plane of symmetry, or sorry, CA's point group, CA's point group. Okay, that will give you CA's point group. Fine. Okay, so next we have tetrahedral. Okay, so next we have tetrahedral. Okay, so suppose I have this A, B, B, B. Okay, so if you have four different atoms attaching with the central atom, so definitely it will be your tetrahedral. That time no need to figure out anything, you just write down tetrahedral point group, TD. Okay, tetrahedral point group, that is fine. Now suppose I am changing one of the atoms, so I am changing it C. Okay, and the rest of the atoms are like this. So now it looks like what? So it looks like your ammonia molecule, you have 3 hydrogen and here you have lone pair, right? So now you can think like that you have C3 axis. Okay, this is your C3 axis, and sigma C2 will be not present here, because if you do 180 degree rotation, suppose I am doing 180 rotation along this, so that time you will get different structure, not equivalent structure. So here only one plane of, sorry, here only C3 axis of symmetry is present, C3 axis. Okay, now if you see sigma V, you have to see sigma V. So suppose I am passing a plane like this containing B and C atom. Okay, this plane actually cuts which atoms? So this plane actually cuts your this B atom, A atom, and C atom. So that time what happens? This B and this B, they are becoming mirror image to each other. So that means you have plane of symmetry which contains your principal axis of symmetry. So that is your sigma V. And if you are able to find out one sigma V, so that means ultimately you will have 3 sigma V. So C3 you have 3 sigma V. Okay, anything is present else? Nothing, right? So you will get C3V point group. Okay, now suppose I am changing two atoms. Okay, so this is your C, this is also C. Okay, this one is your B and B. So that time what you will get, if you have two atoms like this, C, C, B, B, so that time you can think like that C2 axis is present here. If you rotate by 180 degree through this axis like this, clockwise, anti-clockwise, whatever, so ultimately this above the plane B will go to the below the plane, and this below the plane B will come to the above the plane, and this 2C, they are also interchanging their position. So basically these two atoms are interchanging their positions. You have C2 axis of symmetry. Now the next question, is there any plane of symmetry is present or not? Okay, so definitely plane of symmetry is present. If you see, if you contain the plane through this, so suppose this plane cuts your C atom, A atom, A atom. Okay, so if I talk about this plane, so this B atom and this B atom, they are becoming mirror image to each other. So you have one sigma B, so that means ultimately you will have 2 sigma B. If you are, I told you already, if you have Cn axis, you are able to find out only one C2, you will have n number of C2. If you have able to find out one sigma B, you will have n number of sigma B. So this is one sigma B, and the other sigma B will be along your this B, A, B. So that time like this. Other sigma B is like this. Okay, that time what happens, this C atom and this C atom, they are becoming mirror image. Okay, so you have C2 and 2 sigma B, that corresponds to C2B point group. Okay, you have C2 and 2 sigma B, so that corresponds to C2B point group. And if you have 4 different groups, like suppose you have here B, okay, here you have C, then you have here E, and suppose here you have D. So if you have 4 different groups, so that time nothing is present here. Okay, so you can see no symmetry element, so that time you can write down it is belongs to your C1. What do you mean by C1? So C1 means you are rotating by 360 degree only. So 360 by 360 you are getting 1, right? Theta value, sorry, n value you are getting 1. So that means C1 you are getting. Okay, fine. So these are the types of tetrahedral molecules. If you change the atoms, you will get different. This C3B will be the example of your ammonia, and this C2B will be the example of your water molecule. Okay, if you draw the water molecule, so that time you will get the same thing. Okay, same thing you will get. Okay, you can correlate with water molecule, this C2B. Okay, and C3B will be, you can correlate with your ammonia. Fine, so these are the things we have done today, and tomorrow we will start new thing, linear molecule, square planar. Okay, so that thing we will do. Okay, then we will go to octahedral geometry, and now we will only do focus only on this point group, because how to find out point group, that is very important. Okay, in exam they basically gives you the point group, and you have to, they always ask like what are the elements you have present there. Okay, so that actually you have to see. Okay, fine. Okay, so that's it for today. Okay, we'll meet tomorrow, and yeah, thank you.